first thing, the good thing about it is it's an augmented matrix, which means I don't have to do any work by hand. Now, solving systems, an awful lot like solving equations, you can come up with a specific answer. You can come up with an infinite number of sets of answers, or you possibly can come up with no answer. I don't think too many of the exercises they gave you came up with an infinite net of answers, and I don't think any of them had any no answer problems in there. But we've got x plus y plus z is equal to 15. We have x minus 3, y minus 3z equals 21. Minus 21. And we have 4y minus 3z equals 8. That was a negative 21. First of all, even I would actually enjoy this problem if I had to do it by hand. But it's 3 equations and 3 unknowns, and there's a lot more manipulation because you systematically have to write out all the variable x's, and then all the variable y's, and all the variable z's. So it's a lot more work to do by hand, but it's a fair problem in an augmented matrix exercise because all you're putting into the calculator. So again, our steps here would be to access the matrix menu. And we know that that's seconds and x to the negative 1. And after accessing the matrix menu, we're going to enter the coefficients and constants. Now that's probably going to require us to define or redefine what the size of the matrix is that we're using, but that's all part of the entering the information you have in the problem. Then after we get that done, we're done editing matrices, so we have to quit back to the home screen for just a second because the calculator doesn't allow us to move between columns while we're setting up exercises. So that's a temporary thing. That's just one of the little glitches that has to be done. And then back into the menu again. And after accessing the menu, we're now going to make use of the math column. Because in that particular column, we're looking for the RREF command, which is essentially the do all this work for me so that I don't have to do it by hand. So that's the shortcut way of doing things. In the vast majority of the problems, that's the way we'll do it, except for the one problem that they give us on the test that says we have to do it by hand. Okay? So after that, we should be able to, we access the reduce row echelon command, and we point it to the matrix that we're using. And then we're expected to be able to interpret the results. So we have 2 beginning steps. We have 1 activity step where we actually pull in a program, and we have 1 interpretation step. So all this is done in 5 or 6 steps in the exercise. Okay, so that's essentially, that's the short version of what we said when we were looking at what we touched yesterday, or not yesterday, but Monday. So, calculator. Probably would have been here to begin with. Second and next to the negative 1 to get into the matrix menu. Now, obviously I've been using this in class today, so I have some other matrices there. I don't have one that's predefined. You may still have one, but probably don't have one that's predefined. Doesn't make a difference what I had in those matrices to begin with. They're irrelevant. I can rebuild them if I want. But I do have 2 active, and after today we're going to probably see that there are times when we want to have 2 active because of the operations we're going to do on matrices. But basically, edit first, declare the size of the matrix. How many rows do you see?
3.
How many columns do you see?
4.
4. In an augmented matrix, there's always one more column than there is rows because it's got to hold the constant values in the problem. So it's not a square matrix. Okay, but it has the variable side of the matrix, which are the first 3 columns. And here now notice that we don't quite get to see all the columns because we're stuck with the fixed width up here, but we know that when we start typing things in, it's going to scroll and we're going to get all the values that we see there. So it's kind of irrelevant that we don't see all the things that we need to see, but we are trusting that we can put that information in properly. A little bit like the stats menu where you only got to see 7 items at a time, but you knew you had a list that had 25 items in it there, so you knew the row values are out there. And so does the calculator. So just be careful with your double check kind of stuff in the problems. Okay, so now we need ingredients. So the top row values that we're putting in, not the variables, only the coefficients. And those are respectively
1,
1, 1, 1, and then the constant value of 15. Second row,
1, negative 3.
1, negative 3, negative 3, negative 21. And the last row,
0.
we have to have a 0 for the x value. We can't just neglect it. It gets really pissy if you try. In fact, it won't let you. If you delete that value that's off of that value, it won't even let you delete it. If you try to clear it, it clears it off of there, but it won't let you move away. It won't let you move anywhere until you put a number in there. So every cell has to have a number in it, and if there's no value listed, then it's got to be 0, 4, and negative 3, and our 8. So now we're up to step 2. We've entered all the coefficients and constants. Calculator says, well, you told me that you wanted to edit. Now you got to tell me you're done editing, so that's why we have to quit back to the home screen. That's second in mode. Then we go right back into the matrix menu again, and now we see that it's accepted our 3x4 matrix in matrix A. Now we're ready to process that matrix. We're ready to do some work with it. Math column, scroll until we find that command of reduced row echelon form. Pull that command up, and then point the calculator to the matrix that you stuck the information into because it can't read your mind. So we have to go back into the matrix menu one more time, and now we're in the name column, and we're saying pull up the matrix number 1, which is matrix A. Close the grouping symbol or don't close the grouping symbol. It won't make a nickel's worth of difference until you start doing operations on matrices, and then you would have to close the matrix problem here. But if I just enter here, the calculator's done. Now what it's dumped out for me is something that I have to be able to interpret. It puts an extra set of brackets in there just because it's a matrix, but really we see a bracket around each row as part of the matrix. So it does things a little bit different than we would see in print, but not a big deal. So here what we're looking at now is we're looking at a matrix that's just 1, 0, 0, and 6, 0, 1, 0, and 5, 0, 0, 1, and 4, and it's our job to interpret these. These are all of the coefficients on x, these are all the coefficients on y, these are the coefficients on these, on z, and these are our constant values. So literally, this top row is saying that 1x and no y's and no z's gives us a value of 6, or in other words, x has to be a value of 6, and therefore in the same fashion, y has to be a value of 5, and z has to be a value of 4. So that is a unique solution. These 3 lines in 3 dimensions would intersect in only one point, and that is the one point in space where they would intersect one another. We got an answer to that problem. Probably took me longer to talk about how to put it in than it actually did to put it in Word. So less than a minute for that problem, but that's a good 10-minute problem if you try to solve it by hand. So we're not saying we don't need to know how to solve by hand. We're just saying that if we have to solve something by hand, they're going to give us something manageable, not something like this. Okay? So, fair enough? What else?
Are you just doing the first row for that one?
Well, all I did here was wrote down what the first row represents. The second row represents no x's and 1 y and no z's being equal to 5, or in other words, it says that y has to be equal to 5, because if there are no x's and no z's, then obviously I wouldn't need to write them. And then we have no x's, and we have no y's, and we have one z that gives me a value of 4. So I didn't write those other two lines because I kind of thought you'd see that that's what it's really saying in there. But they're never going to ask you to probably write that. But they are interested in you being able to interpret. So pulling out of that menu, what's the importance of all the zeros? Absolutely nothing. They just say those are gone completely. So this is basically saying in here, x is 6, y is 5, and z is 4. And I just wrote it out in the sides of the problem. Okay, fair enough? What else?
So for all word problems, you want us to make the chart?
I would say that the chart is going to be your best friend in word problems. So this was 6, 5, and 4, right? So we have 6 here, tab goes to the next one, 5, and then 4. And good, I got at least one problem right. Okay, word problems. Do we need to look at a word problem?
Yes.
Okay. This is a good one to look at. No reason why not. Word problems. Let me copy it and format it so that I'll have access to it. Paste it there. Make it bigger.